Okay, now members, let us see when we have this case what we actually saw as case today in the first lesson. So here we have two strings, this one and then also this one, and we have a pulley which is fixed and the other which is by this string fixed with that string there. So a diagram just shows a fixed pulley carrying a string which has a mass of 4 kilograms attached at one end and a light pulley P attached to the other end. Full stop. Another string passes over pulley P, so another string is passing over pulley P. So this first one has this kilogram, this weight, and then the other, this mass, and then it's carrying a pulley the other side. And then at this pulley there's another string which is carrying a 1 kilogram mass and a 3 kilogram mass at one and the other end. Find the acceleration of P, 4, 1 and 3 kilogram particles, and also find the tension in both strings. Because we have different strings, tension is going to be different. So if we consider the tension first of all in this string to be T1, also because this is the same string, T1, then this is also going to be T1. Now we have another string, so the tension in this string is going to be for it, it's going to be T2, T2. This one is going to be T2. Also this one is going to be T2 because the string is the same. Because these are, we are going to expect a weight, you get mass times gravity, then this is going to be G, and this one is going to be 4 times G. Now, after doing that, now we come to the acceleration. Acceleration is going to determine everything. Now, because this, when you combine this weight, is going to be heavier than this, we expect that now this one is going to move like this, because when you combine this and this one, the weight is going to be heavy at this side. So this one is going to be pulled in this direction. First of all, I'm considering this and this weight. So it means that this one is going to be moving in that direction. With acceleration A1. So whenever it's moving, even this pulley is going to be moving in that direction. So even this one, and this case, we are going to be having A1. So now that's the idea. When it moves like this, so I'm going to have A1, and then even this pulley here is going to be having A1. Now, science comes in at this pulley. Now, forget about this one. Now let us first focus on this pulley. When you have this pulley only, know that this one is weighter than this. So meaning, we are going to have another acceleration here. This one will be pulled up by maybe acceleration 2, and this one is going to be moved below by acceleration 2. Now, based on only this pulley there, this one is going to be pulled up and this one is going to be pulled down. Now, the overall acceleration of this particle is going to be, because this one is having this acceleration and also this one. This particle is going to be having an acceleration of A1, then plus its own acceleration in this pulley. While this one, because this one is moving in the same direction as this one, I think you can see, in the same direction as this one. That's why we have that. Now, when you come to this one, the acceleration of this particle, you see it's moving there, and then this one is moving down. So this one is going to be A2 minus A1, depending on the direction. So this one is moving, this one determines these two. So if this one is moving downwards, so this one, you see that this one is also moving downwards based on this, it's moving downwards. So the overall on this is going to be this plus this, the overall acceleration. Then this one, because it's moving opposite to this, it's going to be now A2 minus this one. When you do that, the rest are very easy. And after doing this, now you come to the we consider our masses. So we start with a 4 kilogram mass, 4 kg mass. So now here the acceleration is upwards and the acceleration is A1. From RFR, we call it MA. First result, once pushing it up, you see it's going to be T1. This one is opposing, minus 4G, equal to the mass times the acceleration, which is A1. That is the our equation 1. But now I come to this one, 1 kilogram mass, or we come at the pulley at P. So that at P, our acceleration is going in this direction. Still RFR equal to MA. Now we shall get what is pushed. You see that it's going down, but it's going down, it's being pushed by these two. You see that it's going down because of these two. So it's going to be now T2 in this direction downwards plus T2, then minus, of course, you see T2 and this T2, then minus this T1. I think you can see. So, because this one, remember, this one, then T2, then plus T2, then minus the one which is opposite, which is going to be our T1. So our T1. Now you say it's light, so there, of course, they must be negligible. So there, they are going to be having now our mass, which we don't know. So that's why we take this way to be 0. 0 times that ratio, which is a 1, like that. Okay, after that, it's our T1. From there, it's going to be T2. And I call this equation. This was 1. This is now going to be equation 2. Okay, so now when I come to 1 kilogram mass, 1 kg mass, what's going to happen there? So now for it, it's going to be now, this one is going to be moving in this direction. But this one is going to be moving in that direction, relative to that point which is carrying them. So now this one, if I come now, I have this. So that my force, Fr, equaling to MA. Because now my Fr is what is going to lead up is T2 minus B equaling to its mass, which is 1, times its acceleration, which is going to be the overall acceleration, which is A2 minus A1. So from there, our T2 will be minus B, will be equaling to A1, A2 minus A1. This will be equaling to 3. When I come to a 3 kilogram mass, take the mass. Now it's like for it, it's moving in this direction. What is forcing it is the acceleration of A1 plus A2 using RFR equaling to MA. Now the resultant force is going to be, since it's moving in this direction, so it will be this, which will be 3G, then minus the force which is holding it up, I think you can see, which is T2 equaling to the mass, which is 3, then times the acceleration, which is A2 plus A1. So we shall call this one equation 4. Now the rest we are going to do our calculators and we solve this one. So let me get mine. Okay, so now members, let us see now how we solve this. Now, here we said the mass is 0 because the P is light. So the mass is negligible. Mass is negligible. We can take it to be 0. That's why its mass is 0. Okay, so now, this is now I have all you need. I need to get this, you see, this one is having T1 and A1. G is always long. So now, is that I need that this one is having T2 and A1 and A2. So what I need another, maybe if I put this T2 here, means I need now another equation with T2 and A1. So I'm going to use this T2 to get A1. Then I put this into this. So put 2 in 1. So what is our one? When you put 2 in 1, you shall be having now 2 T2 minus now 4G equaling to 4A1. So you can easily divide it through by 4. I mean by 2 we have T2 minus 2G equaling to 2A1. Okay, now if we have that, now we need to use, now we have here T2 and we need now to implement here our A2. So we are going to use these two. How am I going to implement T2? I'm going to multiply here by B, then I subtract. Because This one is the same as 3g minus t2 equaling to 3a2 plus 3a1. So now I want to eliminate, because here I have t2 and a1. Now I'm going to eliminate, I have t2 and a1, so I eliminate this. So I'm going to multiply here by 3. So I'm going to say 3 in equation 3, then minus equation 4. Minus 4. So multiply here by 3, we have 3t2 minus 3g equaling to 3a2 minus 3a1. We are going to subtract this equation. Then we start with negative t2, then plus, which negative 2t, yes, plus, it's going to be plus 3g, then equaling to 3a2, then plus 3a1. We are going to subtract. We subtract this minus this, we shall get 42. This minus this, we get minus 6g. This minus this, it will vanish. Then this minus this, we get minus 6a1. So I think this was our equation 4. I mean our equation 5. This one was our. So we can easily divide it through by 2. Yeah, 2t2 minus 3g equaling to negative 3a1. This one becomes equation 6. Now this one you can easily eliminate this. You can easily eliminate this, or you can easily eliminate anything. So what I'm going to do, I can easily eliminate, if I multiply here, can I multiply here by 2, and then we subtract. So 2 in equation 5, so that I get this coefficient, then we subtract off equation 6. So 2 here we have 2t2 minus 2 there, 4g, equaling to 4a1. Then you're subtracting off equation 6. Equation 6 here is 2t minus 3g equaling to negative 3a1. Then you are subtracting. Okay, this minus this goes, this minus minus, we shall have negative b. Then this minus, we shall get negative 7, 8, 1. From there we can aim this that our a1 is going to be negative b over 7. So what does it mean? It means that this acceleration a1 was supposed to act in the opposite direction. That's what it means. This means opposite direction. Then from here, after that we can get our t2. Our t2 from there, we shall get 2a, when you take it their side, 2a1, which is going to be negative b over 7, then plus 2b. So our tension here is going to be, this is going to be 14 minus 2, which is 12b over 7. So we have also the tension in the first string. Okay, if we have T2, we can get T1. So our T1, remember, is 2T2, which will be 2 into 12 over 7b, which will be 24 over 7b. So we have that, we have got this, we have got this. What are we missing? We are missing the acceleration, A2. Where can we get A2? So, if I can get A2, which one is easier to get A2? From 3, I'm going to use this now. From 3, my A2 will be, this A2 is going to be T2 minus B plus, now, A1. So my A2 now will be our T2, which is 12 over 7b minus b, then plus a1, where is now a1, negative b over 7. So now our A2, from there, it's going to be, now we shall get this, and this will give us 11. 11 minus 7, that's going to be 4b over 7. You try to check, these are always put these are meters per second squared, these are newtons, these are also newtons, and these are also meters per second squared. Okay, 12 minus 1, that is 11. 11 minus 7, that will be a 4. Yeah, I think we are on the right track. So this is our A2. Okay, so if that is our A2, now we come and we get the pulley, the acceleration of the pulley. The acceleration of the pulley, remember, it's A1 here. Acceleration of the pulley, then so part A, number 1, acceleration of the pulley is going to be, number 1, acceleration is going to be, remember, and the pulley is going to be A1. It's A1, which is equal to 2 negative v over 7 meters per second. Number 2, the 4 kilogram mass, acceleration is equal to 2. Remember, acceleration for the 4 kilogram mass is here. It's going to be A. But it's now, this one is going, we say this is going down, so this one is going upwards. So meaning our acceleration there is going to be, now, the one we considered, where is it? This one, A1 from, you see it was going, it means that it was going the other way around. So, negative means it's going the other way around, just. So it's going to be now D, negative D over 7, which we can take as a positive. So this one shows you that we consider the direction which is opposite to what we had to consider. Then 2D, then we have 1 kilogram mass. 1 kilogram mass, its acceleration is going to be 1 kilogram mass is A2 minus A1. A2 minus A1. Our A2 is 4D over 7 minus A1 D over 7, which is going to be 5D over 7. So this is going to be 5D over 7 meters per second. You put in your D. Then when you come to a 3 kilogram mass, 3 kg, our acceleration is A2 plus A1, which will be our A2 is 4D over 7. Then this one is going to be A2, which is minus D over 7. So our acceleration here is going to be 3D over 7 meters per second. Okay. What about the tension in the springs? So the tension is in the spring. This is part B. Our T1 is going to be the 12 over 7D newtons. Then T2 is going to be 24 over 7D newtons. And the question is done. So that's how you handle those things there. I wish you well. So this negative means the acceleration is in the direction we had it to take. So meaning that this pulley was supposed to come like this, not like this. So this one means the negative, this one will go negative, then this will go also negative. So meaning the direction is in that order. So that's why this acceleration is just taking you the opposite side. Or if you do this, now you can put this negative just indicating the direction. But acceleration can't be, if it's negative, then you say it's retarding. So, or you can write this as D, or you can write this as D over 7 in the brackets. Then you put that now, because it was going, where is, which one did I, this one, D over 7, A1. If it was going like this, now it's set downwards. So it's up to you, or upwards. Okay, so that's it. Okay, now members, I've substituted for you. After getting the substituting the D here, then the D there, here we said you can give it as a negative or it's 1.4 meters per second. This is per second. This is acceleration downwards. This one is because it was moving upwards, then you can say downwards. Here, because this one was moving downwards, so you can say upwards. So this one can be 1.4 meters per second. Now it's downwards, then you say upwards. And then you ignore the negative. Then here, the idea was to put in the D. Remember, our D is 9.8. Then when you substitute in there, that's what we have there. So don't forget to subscribe to the channel. See you in the next lesson.